Hi, I'm Doug Black, Editor-in-Chief at Inside HPC, and we are at the ISC 2022 conference in Hamburg. And with me now is Dion Harris of NVIDIA. And Dion, what's your title now?
Yes, I'm the head of technical marketing for HPC AI and Quantum at NVIDIA.
Okay, so what are you guys really talking about and focusing on at the conference this week?
So this is supercomputing. So of course we're going to highlight, we're highlighting a lot of our big announcements around supercomputing. So we unveiled some details around the LANL system. So what was going on with their Venado system, and so again that's a 10 exaflop AI system that we're really excited to kind of unveil there. And it'll be the first system in the U.S. in particular that'll be based on our Grace superchip as well as our Grace Hopper superchip. So again, you have a cluster that's CPU only, which is new. Of course, we just introduced our Grace CPU last year, and so now this will be the first instantiation of that. And of course, it'll have the Grace Hopper superchip with the accelerated, tightly coupled CPU-GPU pairing as well. So really excited to see that come to market.
So Grace is ARM-based, am I right?
Correct.
And the difference between the two is that Grace is just CPU, Grace Hopper is the two. I got it.
Exactly. So when you look at what we're announcing with our Grace superchip, that's essentially two reticle-sized chips that are tightly coupled, what we call our NVLink-C2C connection. So that gives you almost a full terabyte of bandwidth across that. So you have full connectivity, full shared memory, 144 cores. So a very, very powerful system that, again, will really build for HPC and AI and tackling a lot of those major workloads.
Tell us a little bit more about the system at Los Alamos.
Yeah, so it's going to be at Los Alamos, and it's configured. HPE is the OEM, and so it'll be using their Shasta configuration. But again, I think we're really excited to see what it will do for science. Again, I think we're very adamant in working with them that it's not a flops machine. It's really about how we can build it to really advance science. And so they have some incredible applications that'll take advantage of it. Everything from AI and the fusion of HPC and AI to your classic simulation models, to even some digital twin type use cases. So really exciting.
And the expected peak performance again is?
So basically in terms of AI flops, which is what we tend to lean into because we think that is the future of what will drive a lot of the work. And so that'll be roughly 10 exaflops of AI. So again, it'll be a very functional HPC machine as well as a very capable AI machine as well.
Okay. And could you talk to us about NVIDIA's quantum strategy and what you're doing in that area?
Absolutely. So what we announced, so of course we announced our cuQuantum SDK probably last year around this time, and it was very, very new. We made it available at the end of last year, and just in a short time, we've seen this ecosystem explode. So we have integrations into all the major, quantum frameworks, whether it's Cirq, Qiskit, Penny Lane, and so actually we had some announcements here at the show where we're basically integrating with AWS's Bracket quantum framework, as well as Penny Lane and Xanadu. And so they've announced some key interesting metrics around how leveraging our cuQuantum SDK, they've been able to show a speed up of 900x of their overall system performance and an overall TCO of improvement of about 3.5x. And so we're really excited to see this adoption in the quantum space because we're fairly new to it, but we're really excited because again, it's a very similar workload to what we've seen with say convolutional neural networks. They're using a lot of the same types of math to do the quantum circuit simulations as we've seen with some of our AI frameworks as well. So again, lots of excitement there for sure.
So we've seen here at the conference, Intel is showing their Ponte Vecchio GPU,
Yep.
And of course AMD has their GPUs out. But if you're sitting down with a prospective customer and they ask you, what's the difference between your GPUs and theirs? How would you answer?
Well, I think there are a couple key answers to that question. The first I would say is, we really believe that software is what makes these solutions unique and usable. And so if you look at sort of how we've described our solution, we're really tackling a mix of workloads. So we want our platform to be not just excel at classic simulation, but HPC plus AI. We're clearly, have a long history and legacy of really developing AI frameworks and building in that integration with HPC is sort of a no-brainer for us. But also we're extending that to the edge and thinking how we can bring all the data and the data from the instrumentation at the edge using AI back into the data center. So again, our platform is looking at not just core simulation, HPC plus AI, edge, and then on top of that, we've done incredible work with digital twins. And really when you think about what a digital twin is, It is the amalgamation of all that because it's going to take in data inputs from simulation, it's going to take data inputs from AI surrogate models, and of course, edge in terms of observed data. So we think that we're building a unique platform that's not just a GPU, but has this rich ecosystem of software that can allow you to tackle all of those workloads. And of course, I mentioned just a second ago, quantum. So if you're building a system and you wanted to be able to leverage all of these key workloads of HPC, we think we've built a system that will allow customers to do that.
Great. So we've been with Dion Harris of NVIDIA at ISC. Thanks so much for your time.
Thanks for having me. Appreciate it.